or ion. Can you think of a type of molecule that doesn't mix well with water? Oil. Oil does not mix well with water. And we would say oil is hydrophobic. So the other big vocabulary word here. Hydrophobic are substances that do not have an affinity for water. So the opposite of hydrophilic. That makes sense. The base of these words, hydro, means water. I believe it's Latin. It could be Greek, but I'm pretty sure this was Latin. And then philic means to like or to love. On the other hand, down here, hydro, again, still water. Phobic means to fear or hate. And so these words actually do have literal meaning. Did I mention that hydrophobic molecules are non-polar? What kind of atoms form a let's see. How does a non-polar bond form?
Two of the same elements.
Two of the same elements will form a non-polar bond. You have something else to add? Yeah, it wouldn't be oppositely charged. And the other part to it is the two atoms would have equal, remember that other big vocab word? Equal electronegativity. So if you formed a bond, for example, between oxygen and sulfur, it would be nonpolar. It would be a weird molecule, but it would be nonpolar. Actually, it would be separated. And I'm going to talk about in a little bit another relationship that is a nonpolar relationship between atoms that you probably would have thought would form a nonpolar bond. But we'll get to that later. So that's an upcoming teaser. We're going to get something exciting there. Okay.
Is gasoline nonpolar?
It doesn't mix with water. Methane is nonpolar. But I think there's alcohol in it, isn't there? If it has ethanol in, it's not completely
It's
good at dissolving. It's an excellent gasoline and other alcohols are really good at solvents when it comes to oils. And I don't know. It must be something. I don't know. It's a good question. Mm-hmm. The question is alcohol or no gasoline nonpolar, and then a laundry detergent nonpolar. Now, laundry detergent is not nonpolar. It has. It's been a while since I've reviewed this, but it has characteristics that allows it to dissolve oily substances and other non-odd substances like gasoline. And I don't know. I can't remember what the formula for gasoline is. Any other questions? Okay, so are you guys okay with what hydrophilic and hydrophobic means? Then our next topic about water is actually about pH. And you guys are probably somewhat familiar with pH. You might even know that acids have a low pH, and bases or alkaline substances have a high pH. So that's familiar to you? No, yes? For a few tidbits on pH. pH is a scale between 0 and 14. And it is a measure, this part you probably didn't really know. It is a measure of the proportion of a couple different ions. And the two ions are hydrogen ions and hydroxide ions. hydrogen ions are noted with an H and a plus sign. And it's an ion because it has a charge. Remember we talked about this on Monday or Tuesday. What kind of charge does a hydrogen ion have? It has a positive charge. And so does it have more protons and more electrons? It has more protons. And now, let's take that a step further. If you look at hydrogen on the periodic table, you notice it has a single proton. That's all it has, is one proton. Everybody see that number 1 up there is the atomic number? So typically we would start with hydrogen having how many electrons? 1. We take away the electron, then it has none. So the hydrogen ion has no zeros in electrons. Does the hydrogen ion, or even the hydrogen atom itself, does it have a neutron? How can you tell that? No, this is out of the camera here, but I'm looking at the atomic mass underneath the letter there, and the atomic mass is a 1, which is the same number as its atomic number. And then the mass, remember, is the number of protons plus the number of neutrons. So does hydrogen have neutrons usually? No. So, you know, that actually makes hydrogen ions really cool because they are like the smallest elemental atom that you can get, and it only has a proton. In fact, the hydrogen ion is a proton. So if you hear about just protons being talked about, proton flow, proton force, proton gradient, we're talking about hydrogen ions. And in physics, we might just talk about protons. They don't care what element it is, it's just physics, right? So when you hear that in your physics classes, they're talking about hydrogen